Right. What we were discussing last day is about functions. So we just learned functions and parameters and how functions work. Basically, for these functions, parameters are inputs. So when parameters provided, so we can use different values in the different instances, and we can customize functions according to our need. We have done several functions, including finding the area, finding the circumference. Also, we have created a function using turtle library to draw different shapes, symmetric shapes. We have created that as well. These functions are customizable when at the execution point. Users can input different values and so run according to their requirement. Actually, it is reusable. Once defined, no need to run again and again. So once the file is executed, you can run the function and get it done, get the task done in different times. That is about the function. So today, what we need to learn about this returning and non-returning functions. So basically, this is very simple. So the functions that we have discussed yesterday, all these functions were doing some process. Basically, these kind of functions are called procedures. Actually, when you execute it, so there will be a result. But there are some functions, when you execute these functions, you will not get a result immediately. So instead of that, you will get a result which can be saved and later used for your requirement. So let's see this. So let's practically see the difference, then you can easily understand rather than explaining the note. Let's have two functions and compare them. The function number one, the ordinary function that we have described yesterday, let's say function def hello is my function, and this function is basically printing a message called hello world. This is the simple function that we were talking yesterday. No parameters, but you can even add parameters too. Maybe you can say hello. Okay, let's say hello is my function, and I just need to put the hello p or hello c or p. P is a person. So first thing is, let's say p equal world. So initially, when I ask you to print, it will print hello plus p. That means will be hello world. So let's run the function. Okay. When you run this function, say hello. By default, it says hello world, but you can even give hello something like this, and that will be edited as hello Dasun. So by default, without any parameter, it will be executed hello world, but with a parameter, it will be printed the parameter value. So that is this parameter E about. This is a normal function. But a returning function, the other hand, so you can define the same thing return function, but here, let's say hello R for the returning function. Looks similar, everything looks similar, but instead of printing, you can just return. That's the difference. Instead of printing, just use return. Let's see what will happen. So the first function, hello. First function, hello, when you execute. So this is what happened. With a parameter, this is what happened. The second function, hello R, without parameter, hello world within single quotation, hello R with a parameter, let's say Dasun, say hello Dasun with quotations. But here actually you cannot see much difference instead of this quotation in the second one, the returning one. But there is a special thing that we can do with these returning functions. The first function, So result, hello. If you tell like this, it print this. If I try to print the result, nothing is there, right? Similarly, hello, Dasun, it will print this. If I try to print the result, nothing is there. But the second function, hello R. Let's say result equal hello R. Now you will not be able to see anything. Nothing is there. But if you print this result, you can see the hello world is stored. That is the returning function. Returning function can store the value. When you run the function, it will not be immediately printed. It has ability to store the value. Later, when we need that, you can get it printed. Similarly, let's say result hello R function, return function. I'm going to say and when I try to print this, so here nothing happens, but when I try to print this, it has the value stored there and that will be printed. That is what the returning function is. It's very simple. So let's write down this with the comparison and the note quickly, because this need to be written as this part is very important. Yeah, please write down the highlighted one up to here. And the relevant code is also given. Please write down it quickly and try this. Right. The next is the returning function can save the value, as we said, like then later we can. So when you're running this, the value can be stored. So this is what it can do. Then the recursive function. Recursive function is a special returning function. So actually what that can do, that can recall the same function. Recursive function is basically a returning function. It can even be a non-returning function. So that can call the function itself. Okay, let's see this. So here we have discussed returning recursive. So let's see a recursive function, right? So then you can just understand what is happening there. Okay, so let's say there's a function. This function is basically, I want to define a function. We just forget about this, what you see here. So just see this, there's a function def, let's say print num. This function is basically printing nums up to 10. Let's assume it's printing nums up to 10. So let's say limit. Or I'm telling L or end is 10. Default value is given. Okay, what I'm going to do now? I'm going to print 1. Print 1. Or print. So let's say start is equal to 1 and end is equals. So I'm going to print S. That is here number. By default, it is number 1. Actually, before printing, you can check one thing. If S is less than E, then do this. That is for the security. Otherwise, somebody can view 10 and 1 here. So here they are checking whether S is less than 10, then printing S. And after printing S, so after printing S, what I'm going to do, this is called recursive function, right? So I'm going to call the same function. That function name is print now. Print S, and I'm going to call the same function after this if statement. I'm going to call the same function, but this time I'm going to call S plus 1. S plus 1. Previously S was 1. Now I'm calling for S plus 1 and keep the remaining as it is. End as it is. So here within this function, I'm calling the same function. Okay, let's run the function and see. I have not created any loops. So please remember, I have not created any kind of loop. Instead of that, I'm now using print num function. and I'm giving start as 1, or I can just keep the default and move, right? Because defaults are start 1, and I can keep the default and move, and you can see here. Okay. So it's going up to this, and what has happened? Okay, here also I think I need to give 10, right? So let's run this now with the defaults. Oh, still. If s less than this, do this. I need to write, I think, else. No, else is not needed. If s less than this, print s. Then print num s plus 1. We are always checking whether s is less than e. Okay, anyway, it's printing up to 9. That is good. So let's give it the values then. 1 and 10. Still, it's going up to num, going up to this, and when it reaches, okay, let's use this inside, right? I think that is the error. Okay, print num calling. Yeah, that is the error. That is the problem. But I have to like make it equal to this also, because like if it is less than only, I need to recurse. Otherwise, like no need to think about the recursion. So let's put the values. By default, it is 110. It's printing 1 to 10. And if I try to print without any, so it will still call the defaults and print up to 10. And if I try to give the starting digit a different digit, it will go from 4 to 10. If I change this like 10 to 20, it will go from 10 to here. The end need to be continued. Like let's take recursion again. So I have to reassign the starting end, and you can see it's going up to this. So print 4 will start from 4 and up to 10 will be printed. Okay, good. Print 110 will print up to 10. Okay, print empty will print the defaults, that is 110. Okay, print then different start will start from that, and different end and start will go from different start to different end. Yes, it's happening. It's like I have not used any kind of loops here. That is the specialty. I have not used loops. Instead of loop, I have recalled the same function based on a condition. There is a condition, but I have recalled the same function again. So we call that a recursion. Just try this. Let's try this. And then I'll give you a self-practicing exercise. Print even numbers from 1 to 10. Then odd numbers from 1 to 10. So try to do these things. We have already done this, but using loops. This time what you need to do, so we have already done this actually using loops, but this time please use recursion only, right? Use recursion and please do these activities. Only use recursion, right? Don't use any other. It's only recursion. Okay, you can start practicing this and then try these things. At least try to do 3 out of these questions. There are like 1, 2, 3, 4, 5, 6, 7 questions. At least try to do 3. Okay, even is correct. Even numbers, you're starting from that, starting from S, printing S. Next will be +2. Okay, correct. Odd is starting from 1, next is +2, and even is starting from 0, next is +2. Correct. And square, and okay, so when you're printing only, you need to do the difference, like very it's only small mistake there. So in the square one, can you just do something like print S into S? Change print S into S in the square one. Yeah, S multiplied by S. In the print statement, change it to S multiplied by S. Okay, then print S, the S square, the recursive function, call S plus 1. For the recursive function, call it, because the next will be 2 plus 2, right? 2 into 2, next will be 3 into 3. Okay, now we can just try. So the triangle one, just erase, otherwise this won't work because that has error. The complete one you can erase up to def, or you can comment that part, because this has error because this is incomplete. Erase 4 lines, last 4 lines, including this line. Then run it and see whether the square is working. It's printing, right? Okay. It's not difficult. It's not difficult at all. It's only you have to change the printing line. So similarly, you can print triangles if you think. Okay, so let's move to this. And okay, odd and even using the recursive function. Let me repeat. So print, the first one is print even numbers from 1 to 10. You can start from 0. Here, actually, you can go 2 plus 2, right? That is the easiest way. Print, let's say print even num. Here, print even num. Let's copy this and paste it one more time. The odd nums can be done, like odd nums can be printed as you have done. You'll start from 1, go 2 by 2, this time odd num. That will print the odd numbers. The square numbers, similar way. You can start from print sq num, let's say sq num, and here also print sq num. Go 1 by 1, but you are printing S into S. So starting from 1, then this will happen, that is square numbers. For the triangular numbers, you have to give a try like this. For triangular numbers, let's say print tnum. Here also I'm editing as print tnum. Starting can be done like this, like, so you need to create this triangular number. You can start from 1, and the first triangular number, let's say tn equals 0. The first triangular number can be built tn equal tn plus this s, and print the tn. So you can add 1 to this. So let's try. I think this should work. Print tnum. You just no need to give the starting and ending as there are defaults. Oh, it's going on. Print tnum. You are incrementing s by, oh, this is always 0. When you start, that is the problem. It should be defined early. Refer to the same global tn. Otherwise, this will be reset to the 0, right? Let's try it again and print the triangular number. You can see it's printing from the initial 1 to So it's printing from 1 to 55. That happens. That is how you need to print the triangular numbers using recursion, because you are storing the triangular number, starting with the triangular number 0. But later you add 1, then add 2, then add 3, then add 4, because 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, that plus 5 is 15, that plus 6 is 21. You keep adding incremental to the existing triangular number, and and that way you can print the triangular number. But you can do this only one time, right? If you try to print this again, you can see these numbers are wrong. These numbers are not triangular numbers. Actually, you have to start from 0 again, right? You have to start from 0. The TN, you have to say, I think the global TN, you have to start from 0. You have to reset that to 0 in the initial level. When S is 1, Tn should be 0. And when S is 1, Tn should be 0. That only in that time, right? That you can reset if S equal to 1, then you can say Tn equal to 0, right? That is the only occurrence where Tn becomes 0. So let's run it again. I think this time you can run 2 times, otherwise like it's giving an error. Triangular number, you can see it's printing again triangular number, resetting is done. This way you have to reset, otherwise there will be a problem. Only when S is 1, the Tn should be 0. Otherwise it's not beginning from the start. Okay, this way you can print these numbers, but the patterns, try to identify the patterns and apply this to the patterns too. Just try. I'll explain, but just give a try. At least take 5 minutes and give a try to identify the pattern and just to generate. We have done this already, right? In repetition, not in the recursion. In the repetition, we have done. So if you can understand the pattern, what you need to do is you have to implement. This is like just adding the previous 2 numbers. 1 plus 1 is 2. Then 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. Likewise, adding previous 2 numbers. So this can be done easily. So let's say I'm going to define this as a pattern. So let's say pattern 1, PAT1. And this pattern 1, actually what I know is currently, let's say pattern, the nth item, I'm going to get the nth item. If n is equal to 1 or n is equal to 2, you know the value, so I can use a returning function. I can return 1. So if the first and second digits are 1, right? So I can return 1. Else, so what is the n? So I can say return. Basically, it is the addition of, if n is equal to 1 or 2, this. Otherwise, you have to just add the previous 2 numbers. You can say return n minus 1. Return. You can say pattern 1. The pattern 1, I can call n minus 1. Right, pattern 1, n minus 1, and plus pattern 1, n minus 2. Okay, let's give a try. Just need to save this, run this. I need the pattern 1. You can see it's 1. Pattern 1, 2. This also 1. 3. 3 is 2, right? 3 is 2. Okay. Then the 4th one, it's 3, right? Okay, that is also correct. Then 5th one, right? That is 5, right? Okay. 6th one, that is 8. Okay, I'm getting there. So the previous one and plus 1 before that one. Right? What will happen actually when okay, let's put some value and see what will happen. So let's say I have given pattern 5. I need the fifth or sixth one. Sixth one is 8, no? Sixth one is 8. If I give 6 there, 6. Then is n equal 1? No. N equal 2? No. Then it will go to 6. And then it will call 5 plus 4. Actually, you are calling now. I'm asking, I need pattern 1, 6. When I ask the system, ask the function to find that, it will check whether n1 or n2 no, then go to the else. Then it is checking pattern 1, n minus 1 is that this is equal to pattern 1, the previous 2. N minus 1 is 5, n minus 2 is 4. Okay, then this is equal to 5. When this is 5, is it a 1 or 2? No. Then 5 equal to actually 5 is equal to pattern 1, 4 plus pattern 1, 3. That is 5. Actually, 4 is equal to this 4. That is equal to pattern 1, 3 plus pattern 1, 2. Still, you don't know what is 4. But you know 4 is equal to 3 plus 2. That you know. But you don't know what is 4. You know the 4 is equal to 3 plus 2. 3 is equal to 2 plus 1, right? Hello?
Yes.
You got my point? 3 is equal, this 3 is equal to 2 plus 1. 1. 3 is equal to 2 plus 1. Then, okay, now you found this one. 4 equal to 3 plus 2. 3 is equal to 2 plus 1. This 3 is again equal to 2 plus 1, right? I have to write this again. 2 plus 1. And this last one, 2. Do you know when it is 2, what is the answer? N equal to, it is 1, right? That you know now. You know the answer is 1. Understood?
Yes.
Right. Okay. Then the next line you can say 3. 3 is equal to 2 plus 1, right? 3 is equal to 2 plus 1. This 2 you know. 2 is already 1. Next you have 2 again. This 2 is also 1. 1. 1 is also 1. 2. 2 is also 1. Then 1. 1 is also 1. 2 is also 1. Now it is 1, 2, 3, 4, 5, 6. And you know 1 is 1, 7. And this is also 1. So altogether you will get the answer 1, 1, 1, 1, 1, 1, 1, 1. So how many ones? 1, 2, 3, 4, 5, 6, 7, 8. And the answer will be 8. So this is how the recursion happens. You can explain, right? So initially pattern 6. So if you want to find what is pattern 1, 6th item, so then what will happen? It is equal to 5 plus 4. So 5 plus 4 is the 6th item. Actually, 4th item is 3 plus 1. 3 plus 2, sorry, 3 plus 2. Then the 4 will be, this 4 will be, so this 4 is equal to 3 plus 2. And this 3 is equal to 2 plus 1. That is this part. The next part, 3 is equal to 2 plus 1. And you already know the 2 is equal to 1. That you can write. Then actually this 3, you can say this 3 is equal to, this 3 is equal to 2 plus 1. Okay. Then this 2 is actually, this 2 and 1 will be 1, and here also 1. This 2, 1 and 1 will be 2, 1, 1 will be. So this is, there's another bracket. This 2 and 1 will be 1, 1. So 1, 1, and this will be, this one will remain as 1. 1, 1, 1, 1, 1, 1, 1, 1. Okay, only one is there. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Then this is 2 and 1. Actually, this 2 I need to write. This 2 is also 1, right? That I need to write. This 2 is also 1. Then how many ones? 1, 2, 3, 4, 5, 6, 7, and 8. 8 ones. Okay, this is how it is executed. But execution part, you don't want to worry. You need the algorithm. This is the algorithm. Actually, then how can you print these numbers as a sequence? I'll comment this. I'll comment this part. I just gave this you to understand what is happening there. Then how you can print these numbers? Easy. You can use one of the previous. You have printed from 1 to 10, right? Yeah, this function has printed 1 to 10. Let's use that function. Print num, you're going to print from 1 to 10, but this time instead of print s, you're going to print pattern 1 s. Pattern 1 is this pattern. Actually, you are using this recursive function inside this recursive function. And let's end with space. Okay, that is print num function. So print num function, let's say print num pat, print num pat. Okay, save, run it. Now I'm executing print num pat. You can see it's printing from 155. Okay, this is bit complex, bit difficult than the previous one, I know. But no need to actually, in your level, you don't want to figure out this in one go. But if you can understand now, that is enough. Can you understand this now?
Yes.
Okay, then that is enough actually. I just wanted you to try. But so this one also similar. The next pattern is also similar, much similar. You have to just give a try. Just try to figure out. This will be easier than this one, but similar. Give a try to do that as a homework. Please copy down, take a screenshot of this now. Can you take a screenshot of this? This one and this one, how we have applied and full screen screenshot. Okay, done. Hello.
Yes, no, I finished.
Okay. Then I'll be discussing the remaining part next week, right? Okay, have a nice day. Bye.
Bye.